consider the idea of doing regression with that curvature and different categories. So for the example we're going to use, we have 3 different antivirus software programs that I made up. Dewormer, Guard IT, and Trust Me, which frankly that kind of sounds like they might be viruses pretending to be antiviruses, which we've seen that before. Norton! And what we're going to see is a cubic relationship between B stands for the budget and how many attacks come in when your computer has this antivirus, and it's made up, so whatever. But the fun part is, notice I want to have completely different cubics. And normally on the other set of videos, we would have gone through the output and then the equation and finally worked out all 3 different cubic equations. Let's go backwards. We're starting with the punchline here. These aren't the right numbers. I've made these numbers up. But how would this work? Well, we would have our baseline, which since R does it alphabetically, the baseline is going to be dewormer by default. So there's our baseline. Notice I've turned these numbers red because for the next one, it would have the baseline plus something else. And the baseline plus something else, baseline plus something else, baseline plus something else. And for Trust Me, same, with its own plus something unusuals. So the LM statement is going to need to have the budget. That's how we get this guy right here. And the budget squared and budget cubed. That takes care of our baseline. And then company, which allows the intercepts to change. Budget times company allows these ones to change. And then budget squared times company for these ones, and it looks like I left out the budget cubed times company, which you would need in order to get different budget cubed coefficients for each of the companies. So with this as our introduction to where we're heading, let's look at the data set, which is called malware. And this data set has the company, it has the budget, and what we want to predict is how many attacks are we going to have on our fictitious server or website or home computer or whatever. So if we look at the plot of attacks, which is capitalized in this data set, wow, okay, that's great. Do you remember, we've actually seen this before in a video. This type of problem happens when R thinks that it's looking at categorical data and it's really not, it's supposed to be numerical. Do you remember how to fix it? You can't just turn them into numbers. You have to turn them into characters and then into numbers. It's one of those funny things about R. And it says there were NAs. Having those NAs is probably what created this mess in the first place. See, there's an asterisk somewhere there. Now that we've turned it into numbers, that asterisk turned into an NA, which is what we want. And now if I look at the plot, look at that. So does it appear that spending more on antivirus software helps attacks? The answer is it doesn't look like it. It doesn't matter how much the budget is. In fact, if the budget's really high, it looks like sometimes you get some really low numbers of attacks. It's just not enough to really say. But can you kind of notice that there's some patterns in here that look funny? That's a hint that there's probably something categorical going on. So if I take this plot and color it differently for each of the companies, now we can see red and black have this swirl going on, and green seems to have an opposite type swirl going on. So what we need, it looks like, is cubic. You can tell it's cubic because it goes 1, 2, 3, right? You can see how, if you wanted to turn this into separate linear equations, you would have 1 line here, 2 lines here, 3 lines here. That's your clue that a cubic is going to go well here. And in this class, we're going to play with polynomials. We're also going to play with logs. You're welcome to use more complex things, but really those 2 should handle what I'm going to ask you to do. But just saying it's cubic isn't enough. It's also cubic by company, because what company you have changes what kind of cubic pattern you have. That means in my LM statement, I want budget, and I want budget squared, and I want budget cubed, plus cubed, and now. So that I can get in my company, and the company times budget squared, company times budget cubed. And that might seem like overkill, like there should be some easier way to just say, I want budget cubed with different companies. Well, we can shorten a little bit, because if I have company times budget, then it's going to throw in budget and company automatically. That's an R trick. And if I have company times budget squared, it'll throw in budget squared and company times budget squared. So I can shorten it this much, but I can't say company times budget cubed and have R automatically give me the company times budget squared. For these polynomials, if you have up to the fifth term, then you've got to manually put in the fourth and the third and the second and the first. Which in this case, if we want budget cubed, we've got to put in budget squared and budget itself. So we can't shorten it beyond this. But let's run it. Let's run both of them. Okay, so I paused the video for like 10 minutes only to realize I haven't told it to predict a tax. That's what I wanted to try to predict. It's the little things. And because it was paused, nobody knows how long it took me. Oh good, we have us a fit. What's our first step after we've run a fit and we don't get errors? We want to look at those residual plots. And because I can see what's going on here, I really feel like this is the right model. I'm pretty confident that I'm going to like the residual plots. Yeah, nice. Follows the QQ line. I don't see any weird patterns. Of course, if I was really concerned, I mean, if this was my final project, I would probably do these big so I could look at them one by one. I'm searching for anything. I don't see anything going on here. Let's take it back to plots one by one and take a look at our summary, which is going to be pretty big. I'm not going to try to sugarcoat it. Wow, that is pretty big. Can we shrink it? Wow. It's interesting. Art does these little asterisks to try to point out, hey, this was really, really, really significant because all these p-values are super tiny. I have great residuals. I have tiny p-values. I feel confident that I have a good model. Can I explain it? Well, let's go back to the picture that we had before, and I'm going to make my prediction, which is based on budget hat. Budget hat was too big of a word. And so then I made attack hat for dewormer, which is way too big of a word. That's all right. If we're talking dewormer, we're talking about the baseline. So I start with this number, but this is in scientific notation. It's times 10 to the 2, so it's actually 2 over. That means it's a 156.7. And then plus, what's the effect of budget right here? See this? Now this is times 10 to the negative 2, so the decimal would move 2 this way. And if you're not familiar with scientific notation, you're going to want to practice. Or there's another trick that I'll show you in a minute. But this right here is going to be a minus 0.04497, right? That's unscientific notation doing right there. And that's times the budget plus, and here's the budget squared piece, which in scientific notation has 1, 2, 3, 4. And then for the cubic piece, I just put plus. It's actually a minus because it's negative. You didn't need to point it out. Okay, so now I need 8 zeros. And I know what you're thinking. This number is so small that why don't you just delete the whole thing? Well, we're talking about 10,000 cubed. That's a huge number. And that huge number times this super small number is actually going to make a difference. And the p-value being tiny right here says, yes, it will make a difference. You need this number and you need to carry out those digits or else you won't get the right picture. Now, how do I do guard it? Well, I'm going to start with the baseline, but I know that this number right here, I'm going to need to add something to it. And then I know that this number here, I'm going to add something to it. So I'm going to have a mess of trying to get this all to fit on the line. But there's the baseline. So far, we haven't made guard it any different than dewormer. So what is supposed to make it different? Well, here's the piece. Notice this guarded piece is not connected with budget in any way. So this is 6.35 times 10 to the first power, so that's going to be a 63.54. And now I need to find the piece that has guarded connected to a budget. Guarded connected to budget. This number right here, which in scientific notation, it's actually a minus 0.00. My eyes have jumped. Man, only 1 0. 4, 1, 2, and then 0. Great. How about this guy? The budget squared for guarded. Here's guarded, the budget squared. There we are. Times 10 to the negative 6 means it's 0.12345, 6223. And now this guy, which I'm not going to have enough room. Let's give him his own line. I need a gadget. I need guard it with budget cubed. Guard it with budget cubed. This guy right here. And again, don't think this number is so small that it doesn't matter. The p-value tells you it does, and it's because we're taking huge numbers and cubing them that we've ended up with such small numbers there. And I went ahead and paused the video while I did the Trust Me group. But you can imagine after all this, I'm starting to worry. Did I get all those numbers right? Did I get all the right number of zeros? Well, one way to tell is by plotting it and seeing. I really feel like I ought to pause the video and try this first to make sure that I'm going to like the results. What, I guess I can always delete, right? If I don't like what happens, I'll just delete it so that you never know. Guard it. Did I capitalize the it? Nope, it's lower. Next time I'm definitely going to call this something shorter, like AHT, attack, hat, trust me. That would have been a good idea. Okay, let's size this out so that we can actually see it. And the black line, really, oh, it's because I didn't run this. That's why we pause videos. Oh, that looks good, right? Here's my black data and that line is going through it. And the red one, it's hard to see because of all the dots, but it's going right through it too. And the green one is going right through the green. Okay, I think I have the right numbers, but this was such a pain. If my line didn't go through the data the way I wanted, I'd be really frustrated. And would I know where to start looking to try to find the error? Probably not. So let's come up with another way that we could try to do this that you might find easier. You don't have to do it this way, but some students like it. Here's what I had before, and here's my coefficients right here. And notice that we have 156, but we could have left this the way R wrote it, which was 1.56 e to the 2, and I made it positive, and the O2 doesn't necessarily matter. And so this was a minus 4.497 e to the negative 2, and the other, and I don't know that this necessarily makes it shorter, but at least the number that you see here is going to be the number that you see, where is that? Budget cubed is the number that you're going to see here. So that way you don't have to try to count the zeros. R is smart enough that it can understand the very same notation that it's giving you. Let's run it and see if I actually made any mistakes, because if I allow you to have this code and there's something wrong with it, that's going to be bad. Black, red, and the green. Oh, good. Except I don't like the legend being at the top. I think maybe it should be at the bottom. I don't know. Okay, now, there is another way that can help avoid all this number putting in and crunching in. I've shown it to you once before, but I want to show it to you again, just because we're getting into homeworks that are complex enough that some students like to see this. So first thing I'm going to do is make a box called C, and I'm going to put all those coefficients in there. So C now has all those numbers that we were just wrestling with. And if I ask it to print it out along with the numbers 1 through, I guess 12 is the length of C here, I can see C1 is this number, C2 is that number. So I can what I had before, and instead of using this number, I can say C1. Go into the C box and pull out the first thing, which is going to be this intercept number. Right here is C4, right? That negative 4.497. So I'm going to say plus C4. It was a negative number, but the negative is attached to the number. So I want to say plus, and then this being negative is what will make it subtract the way it was supposed to be before. This guy is the squared term, which is C5. And then we have the last one, which is the cubed term, that's C6. So, two good things we get, well, three good things. One, it's a little bit shorter. This can actually fit on one line. Also, I don't have to worry about, did I put 1.65 or 1.56? This is going to take care of those numbers. I do have to make sure that I line up C1 and C4. C2 is for the guarded, so it shouldn't be anywhere in this equation right here. Also, R is going to keep track of more decimals than this. We can see 1, 2, 3, 4, 5, 6. We can see 7 decimals right here. R is going to keep track of 12 decimals. And sometimes that doesn't matter, but it's kind of nice to know that the computer's keeping track of things. So let's fill out the rest. This number here is C1, and this number is the guarded number. That's C2. And you know, that took 5-10 minutes to get that all straightened out. I also like that I can see that here's the first term, and there's that same first term plus an additional part, and over on here the same first term plus the next additional part. So being able to do this can sometimes help students see the patterns in there, but I guess I really like this method just because I know that I can totally trust it because the computer took care to... Oh, well, look at those lines. Those lines do not fit the data where they're supposed to, so I messed up somewhere. Oh, I think I see it. Right there. See, remember how I told you if it's a negative number, you don't have to subtract it. The negative will happen automatically. Any other negatives? No, I don't think so. Well, let's find out. Just a second. We can rerun the code. Okay, red and green are both looking really good. That black one. The black one is the first guy. Sure enough, sure enough. Do you see the negative right there? That is supposed to be positive. Try it again. All right. Now, if I'm actually going to put this in a report, do you know what? I don't think that the dots are actually all that helpful. I'm going to turn off the dots. I'm going to make them colored white. Colored equals white. So when I plot it, you don't see any dots because they've all been drawn white, but the lines still show up. Okay, this is my graph, right? I get to say I like that better. Because I want it to look really nice, I just made a main title, and I'm going to size my picture out a little bit bigger, and let's rerun all this. And see, by making the picture bigger, now the legend fits a little bit smaller. There's the picture I want. That's what I'm going to use in the next video to talk about how would you describe what you see here.